All right, so our project was focused on the legal use case for safety evaluation for the scorecard. Um, we obviously were using the two Gemma 4 E2B models, the E2B and the E2B IT. Um, our, um, our data came from two separate data sets, one from the MMLU professional law data set, which is a more multiple choice bar style exam, and then a truthful QA, which has a more open-ended format to the questions. And then there were five metrics that we used to put on our scorecard. And those are factual consistency, sycophancy, calibration, cross-lingual shift, and citation accuracy. And we'll get into each of these a little bit more.
Yeah, so for this evaluation, we tested factual consistency and sycophancy in a legal assistant setting using 100 professional law questions. So the pipeline works in 3 steps. First, the model answers a legal multiple choice question. Second, the user challenges a model with a confident but incorrect answer. And lastly, the model is asked to give a final answer only, A, B, C, or D. We then compare the model's initial and final answers to the ground truth label. And the key factual consistency metric is final accuracy. Did the model still give the correct legal answer after user pressure? The key sycophancy metric is the gold to false flip rate. How often the model started correct but switched to the user's wrong answer? And looking at the statistics here on the screen, the instruction tuned model answered more accurately overall, but was also more likely to adopt the user's false answer when challenged. This is a useful control test of legal answer stability, though it does not replace broader testing of open-ended legal reasoning that we will get into.
All right, so for the calibration analysis, the idea was to essentially prompt the LLM after its initial response to also record its confidence on a scale from 1 to 10, 10 being 100% confident that their response was correct, 0 being, extremely unsure. And the main takeaway here is this middle box here, which reveals that when posed in like a quote adversarial question or like tricky / misleading question, the Gemma model was only right 40% of the time, but expressed a confidence of 87% on average, so between like an 8 or a 9 on that 1 to 10 scale, which is obviously not great. When asked a non-adversarial or like more straightforward question, it was right 71% of the time, and its confidence was again in that 8 to 9 range, which is better, but still not ideal. So yeah.
For our cross-lingual shift, we used this as our main metric for being able to handle other languages. We decided to choose Spanish and Basque as our other languages, one being a much more common language with a lot of translation materials publicly available, whereas Basque is much less widely used with less available on the internet. And we found that there was a slight degradation in its Spanish, but a real degradation when translating to Basque. We have determined that a pretty fair cutoff for this would be 0.9 for deployment, but clearly the Basque and definitely many other smaller languages do not hit that threshold at this point, and this is a clear gap in our model.
So given the use case as a legal advice chatbot, citation accuracy is a crucial metric for evaluating model safety here. So 4 conditions underlying citation. So does the citation actually exist? Is a citation precise, i.e. does the cited source actually say what the model says it does? Are quotes pulled from cited sources faithful to that source? And how many claims carry a source at all, or carry a citation at all? All right. So naturally, the topmost concern is ghost references, i.e. the model hallucinating or just making up a reference. Based on the data, it does not appear that the model is hallucinating, not ghost citation, but rather it has a tendency to undercite. As you can see, only 43 of the 102 cases were attached a citation, and 34 of those 43 were unverifiable. So I mean, even with a recall rate of 0.42, it's not great.
All right, now we'll go quick here, but one of the takeaways in regard to using these LLMs as judges is that the quality of the model matters a lot. In the case of the calibration analysis, we began by using the 3 billion parameter Quinn 2.5 model and saw an extremely harsh judge, but when we extended to the 7 billion parameter judge, we saw more reasonable responses in regard to the truthfulness or correctness of the Gemma model's answers.
So in terms of limitations, right, multiple choice bar exam questions are measuring knowledge recall. It's not open-ended advice or drafting. And also considering from the language perspective, only 100 items per language were tested. So few point differences are within kind of a noise range, right? And I mean, Basque being a low resource language, your class is going to be a lot larger. Translations for these, especially for Basque, were generated with an LLM. So there's glossary control and validation. They were not reviewed by native speakers due to time and limitations of resources. So documented caveats likely make the Basque estimate conservative. Sycophancy uses one scripted pressure pattern. All right, so at the token level ECE, it's not verbalized certainty that users can actually see. And lastly, the judge graded metrics inherit judge error because the judge and the models were from the same family, right? So results will be kind of judge dependent, and n equals 64 is going to make that truthful QA noise, estimated something error noisy.
Briefly on our proposed metric, we decided language parity index, which is a function of the accuracy at the non-English language over accuracy in English. As you can see, it does pretty well in Spanish, as we discussed before, at about 94%, but in Basque, it's closer to 64% effectiveness. Our deployment gate is 0.9 for every supported language, which Basque clearly does not fall here.
So in conclusion, we kind of feel like this model should not be deployed as a legal assistant in any language. The ECE is only 0.4. It fails under pressure 80% of the time, and the language parity index is 0.646, which fails for Basque speakers. And so that concludes our hackathon report.